I'm going to take a quick look at a problem that comes up along with parallel lines, and they are called Crook problems. So what Crook problems are, or the basic gist of them, is whenever we have a pair of parallel lines like this, and then we have some type of segment like this in here, and we get these segments here, and some angles that are given to us. So for example, I'm just going to make this up. Let's say that this angle right here is 45 degrees, and that this angle down here is 130. And my question to you is, what is the measure of this angle right in here? So Crook problems they're an interesting type of problem. The reason that they're interesting to me is because they employ a certain problem-solving technique that's important to just understand in general. And that's if we have a problem like this that we don't know how to do, how can we adjust it or change it or manipulate it to be a problem that I do know how to do? And so what we've been talking a lot about recently is if I have parallel lines, they're corresponding angles being congruent, or alternate interior angles being congruent, or whatever it is. And so the question is, how can I take this problem and turn it into something like that? And the answer is, well, just by adding a line. And so when I look at this, the issue is that I have my parallel lines, but I don't have a full transversal here. And so what might be natural for a lot of us to do is to extend one of these segments so that I do have a full transversal, but I'm actually going to do something that makes it slightly more or slightly easier than that. And what that is that I'm going to add in a line that goes through where these two segments meet that is parallel to my already existing lines. And so what this does for me is it creates some angles that I do know the measure of. So for example, this angle right in here, it is an alternate interior angle with this other one up here. So this 45-degree angle. So that means inside here, this also has to be 45 degrees. And then what do I know about this angle right in here? And that is that it is a consecutive interior angle with this 130-degree angle down below. And so it has to be 50 degrees since these lines are parallel. And so what that means is that x, what its measure is just the sum of this 45-degree angle and this 50-degree angle. So in this case, x is going to be 95. Okay? And so that's all there is to it. I'm just going to take these problems I don't know how to do and turn them into something I do know how to do. So let's look at another one. So this is just what's called a Crook problem, but I can also have things like double Crook problems. So I'm still going to start off with the same thing. I'm still going to have these parallel lines here, but instead of just having a single, those don't look parallel at all, but trust me, they are. I'm going to have a double Crook. So something that looks like this. All right. So if I have a situation like this, I'm going to add some angle measures. Again, just kind of making this up on the spot. Let's say this looks like it's about 110 degrees. This angle looks like it's basically 90 degrees. Let's go with that. This one up here is a little bit smaller. Let's just say it's 40 degrees. And I want to figure out what this angle measure is right here. And so what I'm going to do is do the same thing that I did before, and I'm going to add in these lines that are parallel to my given lines so that I can solve for some things along the way. It's just that I have to do it multiple times now. So for example, let me draw right through here. So that's one of my parallel lines, goes through this point, and I have another parallel line that goes right through here, also parallel. Okay, so let me work through some of these angle measures then. So this angle right here is a consecutive interior angle with this angle, so it's 110 degrees, which would make this part right here, it's going to be, 180 minus 110, which is 70. Then, up top, what I can do for this angle right here is that it has to add with 70 to be 90, so this is just a 20-degree angle. And then, I should have, that's better. Now, if I go and look at different color, this angle right in here, it is an alternate interior angle with this 20-degree angle, so this has to be 20 degrees as well. So I've worked all the way up and found a portion of my angle that I'm working with. Now I just have to work down from the other direction. And so I know that, let's go with this, this angle right here is an alternate interior angle with the 40-degree angle, so this has to be 40 degrees. And so that means that finally, x, what it has to be, is the sum of 20 and 40. I shouldn't put that there. 20 plus 40. So x is equal to 60 in this case. Okay. So yeah, this isn't too bad. If I take this problem and just break it up into things I already know how to do, I could obviously do this as many times as I want. If I wanted to talk about triple or quadruple or whatever Crook problem, I could just work my way up, solving for portion by portion at a time, and no big deal. So these are Crook problems. Just another example that we can work through whenever we're talking about parallel lines. And all it takes is just for us to add some additional parts to be able to solve this. Not too bad.